How can one planet be hot enough to melt metal during the day and colder than Antarctica at night? Mercury, the smallest planet in the solar system, swings between temperatures above 430 degrees Celsius and below negative 180 degrees. It has almost no atmosphere, faces intense solar radiation, and hides frozen water in permanent shadow near its poles. This world survives conditions that would destroy most spacecraft within hours. But the real reason Mercury swings between fire and ice is far stranger than its temperatures. But the freezing nights are only half the story. When sunlight hits Mercury, the planet becomes one of the hottest places in the entire solar system. Standing on its surface would feel like standing inside a blast furnace. The sun appears nearly 3 times wider in Mercury's sky than it does from Earth. With almost no atmosphere to block or scatter the light, every ray strikes the ground directly. Temperatures soar past 430 degrees Celsius, hot enough to melt zinc and damage many metals. The surface absorbs heat for weeks at a time because one daytime on Mercury lasts longer than months on Earth. NASA's Messenger spacecraft measured this extreme heat during its mission, confirming just how intense the environment truly is. This kind of heat destroys electronics, melts solder joints, and warps structural materials. Any spacecraft approaching Mercury must use reflective shields and powerful cooling systems just to avoid overheating. Without them, a probe would fail within hours. And yet, despite this furnace-like heat, Mercury still manages to hide something completely unexpected. But the heat is only temporary. When the sun finally drops below Mercury's horizon, the planet loses its only source of warmth, and the temperature collapses. Because Mercury has almost no atmosphere, there is nothing to trap the heat built up during the long day. As darkness spreads across the surface, temperatures plunge to nearly negative 180 degrees Celsius. That is colder than the coldest night ever recorded on Earth. It is colder than dry ice. It rivals temperatures near the moons of Jupiter. No other planet in the inner solar system swings this violently between extremes. Mars has enough atmosphere to soften the drop. Venus stays hot all the time under its thick blanket of carbon dioxide. But Mercury stands alone. It's just one long day. Its surface goes from hot enough to melt metal to cold enough to freeze solid carbon dioxide. And this dramatic collapse reveals the real reason Mercury is so extreme. And this is where Mercury's secret becomes clear. Most planets have a shield. Mercury does not. Earth's atmosphere works like insulation. It traps heat, spreads it around the planet, and protects the surface from radiation. Venus has so much atmosphere that it turned into a runaway greenhouse, staying hot all the time. But Mercury has almost nothing. What exists is not a true atmosphere at all. It is a thin cloud of atoms blasted off the surface by the solar wind. Sodium and potassium drift briefly above the ground before escaping into space. There is no thick layer of gas to hold warmth, no winds to move heat from day to night, no blanket to soften the extremes. So when the sun rises, the surface absorbs heat without resistance, and when darkness falls, that heat escapes straight back into space. Mercury does not slowly cool down. It loses energy rapidly. It does not gradually warm up. It bakes. This single weakness, the lack of a true atmosphere, is what turns Mercury into a world of violent temperature swings. But the atmosphere is not the only thing that makes Mercury dangerous. But even if the temperatures could be controlled, Mercury would still be one of the most dangerous places to land. Its surface tells a violent story. The planet is covered in craters, scars left behind by billions of years of impacts. Some are small pits, others are enormous basins stretching hundreds of kilometers across. The largest, the Calorus Basin, spans about 1,500 kilometers, wide enough to stretch from New York to Miami. Between these impact sites, massive cliffs called scarps cut across the landscape. Some rise more than a mile high. These cliffs formed when Mercury's interior cooled and shrank, forcing the crust to buckle and crack like a drying apple. This creates a surface that is broken, uneven, and unstable. Steep crater walls, jagged rocks, and sharp ridges make safe landing zones rare. On top of that, tiny micrometeorites constantly strike the surface at high speed, adding new damage over time. Surviving the heat is only the first challenge. Touching down is another problem entirely. After all that heat, cold, and violence, Mercury reveals its strangest secret. It has ice. Near the planet's north and south poles, some deep craters never see sunlight. Their walls are so tall that the sun's rays never reach the bottom. These regions remain in permanent darkness. Inside these shadowed pockets, temperatures stay low enough for water ice to survive for billions of years. Radar observations and data from NASA's MESSENGER mission confirmed bright deposits consistent with frozen water, possibly mixed with organic material. On a world that can melt metal during the day, this should be impossible. Yet only a few hundred kilometers from blistering equatorial heat, ice sits frozen in darkness. Mercury is not just extreme, it is full of contradictions. And those contradictions reveal something important about how planets evolve. Even if a spacecraft could survive the heat, the cold, and the violent terrain, Mercury has another danger that cannot be seen: radiation. Mercury sits deep inside the Sun's gravity well, directly exposed to a constant stream of charged particles known as the solar wind. With almost no atmosphere to absorb it, that radiation strikes the surface without resistance. The planet does have a magnetic field, but it is weak, about 1% as strong as Earth's. It cannot fully shield the surface from powerful solar flares or massive eruptions called coronal mass ejections. When these storms sweep past Mercury, the energy release is intense. Radiation slowly tears through electronics, weakens solar panels, and damages instruments. Over time, materials degrade, systems fail. For any future human mission, radiation exposure would become life-threatening within hours. Mercury is not just a world of heat and cold. It is a world under constant bombardment, and surviving there requires more than strong materials. It requires engineering at the very edge of what is possible. All of these extremes are not just curiosities, they are clues. Mercury acts like a time capsule from the early solar system. Unlike Earth, where weather and plate movement erase ancient history, Mercury's surface has remained largely unchanged for billions of years. Its scars are preserved records of the violent past. But the biggest mystery lies beneath the surface. Mercury has an enormous iron core. It makes up roughly 60 to 70% of the planet's total mass, far more than Earth or Mars. Scientists still debate how this happened. Did a massive impact strip away its outer layers, or did Mercury form differently from the very beginning? Answering that question could reshape understanding of how rocky planets form. Mercury also serves as a natural laboratory for studying space weather. Because it sits so close to the Sun, solar storms hit it in their most intense form. By observing how those storms interact with Mercury's weak magnetic field, scientists gain insight into how the Sun affects planets across the solar system, including Earth. The smallest planet may hold answers to some of the biggest questions. Understanding Mercury is difficult. Getting there is even harder. Mercury orbits deep inside the Sun's gravity well. A spacecraft cannot simply fly toward it. As it falls inward towards the Sun, it gains speed. To enter orbit around Mercury, a probe must slow down dramatically or risk slingshotting past the planet or plunging towards the Sun. This is why missions to Mercury take years. NASA's MESSENGER spacecraft spent more than 6 years performing gravity assists around Earth, Venus, and Mercury itself before finally entering orbit. The European Space Agency's Bepi-Colombo mission followed a similar path, weaving through the inner solar system for years before arrival. And arriving is only the beginning. The Sun's gravity constantly pulls at the spacecraft. Thrusters must fire regularly to maintain orbit. Heat shields, reflective coatings, and complex cooling systems protect instruments from melting under intense solar radiation. Every successful mission to Mercury represents more than exploration. It is a demonstration that human engineering can survive one of the harshest environments in the solar system. And yet, despite all this effort, Mercury still holds unanswered questions. As if Mercury were not extreme enough, time itself behaves strangely there. Mercury races around the Sun in just 88 Earth days, making it the fastest planet in the solar system. But while it moves quickly in orbit, it spins very slowly. One full rotation takes about 59 Earth days. Because of the precise relationship between its spin and its orbit, one sunrise to the next on Mercury lasts 176 Earth days. That means a single day on Mercury is twice as long as its entire year. This unusual timing is not just a curiosity. It is one of the reasons Mercury became so extreme. The long days allow the surface to absorb sunlight for months at a time, building up intense heat. Then the equally long nights give that heat just as much time to escape into space. With almost no atmosphere to hold warmth, the temperature swings become dramatic. Even Mercury's weak magnetic field is influenced by the slow movement of its molten iron core, shaped in part by this unusual rhythm. On Mercury, heat, cold, radiation, and even time are connected. And together, they create one of the most extreme environments in the solar system. All of Mercury's extremes point to something bigger. Mercury is not just a hostile world, it is a perceived record of the early solar system. Unlike Earth, where shifting plates and weather erase ancient history, Mercury's surface has remained mostly unchanged for billions of years. Its craters, massive cliffs, and frozen volcanic plains are scars from a violent past that other planets have long since erased. Some regions reveal signs of ancient volcanic activity, showing that Mercury was once far more geologically active. Over time, the planet cooled. As its interior shrank, the crust folded and cracked, leaving behind the towering scarps that still stretch across its surface today. Because that history remains visible, Mercury offers scientists a direct window into conditions from 4 billion years ago. It shows how small rocky planets form, how they cool, how their interiors evolve, and how size and distance from the Sun shape their fate. Mercury may be one of the smallest planets in the solar system, but it holds some of the biggest answers. Mercury is a world of contradictions. It burns under relentless sunlight. It freezes in endless darkness. It is scarred by impacts, bombarded by radiation, and stripped of protection by the solar wind. Yet within all that violence, it preserves a record of the early solar system. Every crater, every cliff, every frozen pocket of ice tells part of a larger story. How rocky planets form, evolve, and survive under extreme conditions. Mercury may be the smallest planet, but it reveals how worlds are built and how they endure.